Hello, everyone. Um, I'm Sujay Murthy here. I'm a TME at the Crosswork Network Controller and the Automation team. I'm super excited to talk about this session on the Cisco Crosswork Network Controller for NSO lifecycle operations using the Observability Explorer from NSO. So before we dig deep dive into the session, this is the agenda for the presentation. Like we look at what is observability, look at the Crosswork NSO Observability Explorer, CNC NSO service lifecycle, what goes within NSO on various states and transactions when a service is deployed. I do plan to show a demo on the two personas for the observability tool using Crosswork and a snippet into the roadmap of what can be expected in the upcoming releases. So what is observability? It is a system that can give you the insights into the day-to-day operations of an application, what steps have been taken, what users have been performing roles, and how the system reacts to any integrated components within the system. So how this is distinguished between monitoring and observability? Well, monitoring tells you where the system works and what was the last timestamp and what went wrong. It monitors the service, but it doesn't point you to exactly where the issue lies. It doesn't give you on a real-time stats as to when a system is performing, how are the internal components integrated within the solution that can cause any bottlenecks or issues, if ever, that may arise. So the pillars of observability basically relies on these three components, like how the logs are generated, like what application is recording, what timestamps are being determined, what data is captured, the level of logging information from critical debug or info. Then going into metrics, that is your application's recording of a data to point what a system looks into the measurement, the time, the operations, the labels, tags, how you can correlate from this information, and finally the traces. That is the progression of a request, how that request is translated into multiple requests towards down south on the applications, on the integral components and the internals to generate those traces, and then provide these traces to any applications that can build those dashboards. So what is a Crosswork NSO Observability Explorer? This is a new cool tool from the NSO platform that does progress tracing data through open telemetry format. It utilizes the collection jobs, processing telemetry information, exporting this information through various dashboards, and integrating with open source visualization tools called Grafana and Jaeger. And Jaeger is basically more prevalent towards tracing, and Grafana for metric collection of the dashboards, building those tools. This tool is available as part of NSO's 6.0 feature and functionality, but we can integrate this into any applications that uses NSO and resides on top of NSO to understand the life cycle of a service that the NSO has to go through. So let's look at a typical example where your service is provisioned through CNC and what happens within the lifecycle of a service. Let's say in a use case where we provision TSDN L2 VPN service, the service request is created through a northbound service intent from CNC, which is then applied to NSO. And from the NSO request, it is doing resource allocations for your service through your resource manager. It gives the state of the resource manager on what the allocation has been determined. And then it attaches this resource manager allocations to your per device internal service, which is, let's say in this use case, a nano service implementation. The nano service implementation will generate this config to push to the CDB. And eventually, if commit queues are enabled, which is to push configs to per device level, the per device transaction will be enabled to push the configuration to the network. But this is a use case on provisioning side. Now, if we look back on the service, there is a commit queue transaction complete, and then eventually there is a redeploy on the northbound to say what is the status of the plan for the services. So this shows what service undergoes through when various steps are performed within the service, which the northbound is actually not aware of what happens within the service. So how Crosswork and NSO can integrate with this distributed tracing and metrics is Crosswork provisions this service from a user through CNC. NSO is deployed with the service intent. The progress tracing is enabled, and the notification stream and trace logs are generated towards an OpenTelemetry exporter or a notification listener. Then this data can be exported to Jaeger to do tracing. That is, tracing helps you to see all the states within the service linearly, and the influx DB to collect the metrics, where you could then determine your graphs to build based on the Grafana's dashboards and create those entities on the dashboards for various personas, like when a service is provisioned or a service is deleted or a service is updated. What use cases is helpful to a developer to debug, and what is essential for an operator to visualize when a service intent is determined. So these are one of the examples that we can integrate with how Crosswork and NSO can come together to determine what is the state of the service. Looking at the use cases, the sample use cases that we envision that is helpful for Crosswork and NSO users are how can we integrate this transactional data through various dashboards, create historical data, create real-time visualization, and then grouping these transactions, right? You want to know what is happening for the longest running transaction, or where was a transaction log within the service. Any ongoing transactions at a given point of time. Let's say with CNC and TSDN, we cater to different types of VPN services, traffic engineering tunnels for SRTE, RSVPTE. And then what is the time it takes to spend across services like IETF, L2VPN, L3NM are stacked services on top of flat models, while SRTE and RSVPTE do not have any stacked services, but they do use, all these services use the nano plan service architecture. So insights into areas becomes really critical for developers or operators. Like developers would like to know what is happening in a state of a service when commit queues are enabled, when the LSA is determined in a service, or what type of code optimizations are needed for the service development. Similarly, for an operator, when he's provisioning from Crosswork, he would like to know what is the mean time and every transaction is taking, or what service operations take a longer duration, what take a shorter duration. So every device and every type of service becomes really crucial for an operator to make those decisions as to when a service should be implemented, if there are any transactions currently ongoing that he needs to wait before he performs any operations to the Crosswork. So let's look at these in action. That is what I do plan to cover, is what a developer would like to see from the Crosswork NSO personas. A developer would like to know what is the service FP, what is the scale and performance insights. A CNC operator would like to know what is the service provisioning and identify bottlenecks in the system. So let me switch screens. So I am looking at here at a Crosswork Network Controller screen, which have services, and I can show you on the home screen. There are not many services that are being provisioned, but would like to see what is the state of the system, and what happens within the services. So as we want to look at first at the persona for a developer, we have these dashboards that are pre-created for a developer persona and what an operator would like to see. So in this case, we've split them across real-time transactions, T-locks, queue length, and split them into overview. That is to look at what are the number of transactions, maximum, minimum length of transactions that is taken, the longest transactions for a specific type of service, and how that is tied to the corresponding component state. The pre-modifications and post-modifications of every type of service, what transactions or what durations have taken time. And then moving along is to look at the wait for transaction logs, service modifications, and the longest device connection or device service spans. So these dashboards are created based off the current data that is currently being deployed and tested in this time span. But what I can go ahead and do is let's look at what we want to run. An intent is what is the longest component state of the service that we want to provision. So let's say in this case, we are switching to a screen on the L2VNM service where we've invoked a sleep action to main to live for every element on the service. For every other service, it will induce a sleep, and so that you could see that the time span increases when a service is deployed. So in this case, I've enabled the sleep. So let's go ahead and provision the service. What I have here to test is running some scale test on through this Postman collection. I have a set of 5 L2VPN services that I plan to run from this intent. So let me click run, and okay, let me delete this. And it's only on the NSO proxy that I would like to run the services. There are 5 services that I would like to create. And let me go ahead and click on creation of the service. So what this will do is it will create 5 services with each commits. It's a TLDP type layer 2 VPN service between node 4 and node 5, and it will create across different VLANs. So when we go back to the developer dashboard, I can start seeing that my time span here is increasing, which is in red, basically to say it is extending beyond a certain threshold that my L2 VPN services are being created. Now, in this objective is why does my service increase on the transaction or the timestamps as it is marked in red? And we look at the other dashboard data is what are the longest transactions that it is running. But if we scroll down on each of this intent, we could see that my initial services did take very less time rather than what it has been taking now that it has increased on the time. So what I realize is there is some transaction state that is holding, that is the plan is taking a long time. And on the component state, when I go back to view at the service, I can look at also the latest timestamp and what are the top times that it would take on a service. So filter on the time and filter on the component on the config apply in the state for the service. Right, so let me go back and probably delete these services and rerun this test because I would like to modify my packages. So I'll go ahead and run the test here to delete these services. In the meantime, as these services are being deleted, I can show you what is the state that the sleep has been invoked in the service. So let me go ahead, add to the sleep, and I will now go ahead and comment this out. So I don't want to invoke a sleep in the service, and then run the test again to see what it takes on the service that the transaction can help, and what is the average time that it may take, the mean time for the service when it is being deployed. So in this case, the services are being deleted. Let's look at the Crosswork Network Controller and see that our previous services that were created are being deleted now since I would be provisioning new services. So the deletion request is still happening, which is in progress. And as this is done, we'll go ahead and do the package redeploy so that the package Python modifications can be invoked into the package. But at the same time, this also can show me on the dashboard what is the current state of the services that are being deleted and what is the timestamp it is taking. So there are successful transactions, there are current transactions that are going on, which is in service. And this graph shows me what is the number of transactions and the transaction length during that time of the service. So the system is quite busy. I mean, as you can see that the endpoint, create endpoint took this time, and the transaction logs, and these are the various transaction phases between validate, write, start, prepare, and commit that shows me for this type of transaction in the service, what is being implemented, and what transactions happen during the timestamp. Right, so let's go back to CNC and validate the service is deleted, which is all good. I'll go back to NSO and I'll do a request package reload on redeploy of this service. And as this is done, completed, I'll go ahead and invoke the transaction to create services. And let me open the same dashboard in this use case to see what is the state of the service. So view, I'm running into this screen here. Let's filter by the timestamp. Right, so deletion is done. We are at the latest timestamp in the screen. So let's go ahead and run the Postman collection again. So on this TLDP NSO proxy service instance, and I'll rerun the test to create the services. And as we now create these services, we should start seeing that the other services, like every other service now, is now not using that quite significant amount of time. We should start seeing them services getting deployed, provisioned much faster. As you can see here now that these services are not taking much time in the use case. So what it implies was any service transactions, anything that the developers might change can use these graphs or charts to see what is happening to the state of the service. What times does it implement and where the transaction is holding up. So right now there are 2 transactions, queue length. So this is increasing. Let's go back to the component state. So look at the view. And probably now the time would be is much better than what we had seen previously. Right. So, well, this is an example. I mean, as a developer, you could always try out from Crosswork if you were to add some new packages, what is the state it takes, and how packages can be reloaded to invoke these transactions. So going back to the other level of persona, which is for the operator, is to look at service provisioning. That is when to make a decision on what endpoints to be added for a service. How do I know, like, what was the time did it take for my previous endpoint to be added in the service? And then identify any bottlenecks in the system. Like if a device is being used for a specific type of service, we know that how much busy that device is and what it could lead to. So let me go back and switch my screen. In this case is I have a different dashboard for an operator. So save dashboard, save because of the timestamp changes. So this is the operator level dashboard. It's a minimal information. That is what an operator would like to know. That is, okay, what is his mean time per transaction? Were there any transaction logs and queue length during that timestamp? And here you can see between the create endpoints, because now since that we've been provisioning layer 2 VPN service, what was the mean time in creating endpoints for the last 5 minutes? Or let's say now if I were to enable for the last 3 hours, I've been provisioning layer 3 and layer 2 services. What was the mean time per transaction for the last 3 hours? The transaction details as to where the transaction log is being held for a longer time, the transaction phases, and the service spans. That is mean time to create per service. So here, as we know that with CNC, we do support various type of services like the flat L2 VPN models, IETF L2 VPN models, the flat L3 VPN service, and the traffic engineering tunnels or services. So what was the mean time that it took for per service type? And the device level operations, like when was the device connect sent, what was the longest device phase? Like for example, in this case, sync from what time, how much time did sync from take for a specific device, any show commands, what was the output, and so on. So this is really classifying what a data is collected from the NSO system and how it could be developed through a dashboard for various personas on an operator or a developer level. So in this case, let's run a simple test. Let me run an L3 VPN service creation test where I'm adding 3-node L3 VPN services, and let's see the time it takes to run the service and create those endpoints. Like as a request, as a user gets this request, if you were to see what it takes as an operation, yes, I'm creating those services. I would like to see what is my mean transaction times and what is the current state of the service that it is taking. In this case, it is showing me like what are the transactions, there are 2 transactions, there are 2 services, and what is the mean time it's taking. And this should refresh like what is the layer 3 VPN nodes, because we are provisioning the layer 3 VPN service across node 3, node 4, and node 5. But I'm not looking at more of the developer level details as to what transaction is taking time, whether it's a config apply state or an init state. In this case, all I would like to know is the high level information that, okay, my endpoints are taking like around 170 milliseconds between services to provision for layer 2 VPN. And then when I have a successive or multiple requests that are provisioned for layer 3 VPN, what is the mean time does it take in creating those endpoints? So here we can see that the layer 3 VPN service took 349 milliseconds to provision the service, while the layer 2 VPNs on our 2-node TLDP type service took around 2.10 seconds per service type. NSO device connect, sync froms, operations happening during that time, and those details. So this really helps what an operator would like to view from a service, what a developer would like to understand more, what is happening to the internals from the service. So this is a snippet of what we had to showcase as part of the demo. And this is a visualization through Jaeger, which I am not showing as part of this demo, but we have it collected as a snapshot, like how the traces from the observability explorer can be exported into Jaeger to look at where the NSO transaction times are increased. I think it's more on a transactional state. You could drill deeper into every types of like when a service is run, what are the pre-modifications, create, fast map, reverse diff set, and the post modification details. So what is in the roadmap for observability exporter? It's a committed feature for 6.1 release, which will be available in April. The observability explorer package will be aligned to the changes that the NSO platform will offer, that through OpenTelemetry API options, supporting of parent span ID and span ID for data conversion, building more telemetry feature rich set by adding support to the counting framework metrics, the newer framework metrics that will be available as part of the NSO platform, so that you could aggregate your metrics over a period of time and showcase and address that with your infrastructure or applications. The tail of NCS metrics defines how you could collect those data around various levels of users for a developer versus attack versus an operator level, and then implementing some polling data collection. But likewise, eventually, if you see any issues, please feel free to raise defects. And I know everyone is much aware here, like how to file those defects, and the team will definitely address this with your use cases. So with this, I would like to end the session, and I hope this was useful, and thanks for watching. Have a good day.